Most motorcycles are designed to meet rules. This one was designed to ignore them. The Kawasaki Ninja H2R isn't just fast, it's mechanically extreme, structurally overbuilt, and legally unwelcome on public roads. In this video, we're breaking down the forbidden engineering choices behind its supercharged core, aerospace-inspired systems, and the decisions that pushed it outside normal classification. Stay with me, because once you see how and why this machine was built, you'll never look at performance engineering the same way again. Kawasaki has never behaved like a company trying to be sensible. Where most manufacturers treat limits as guardrails, Kawasaki has long viewed them as mile markers, points on the road that show where others ease off. From the beginning, their identity was never rooted in balance or restraint. It was built around force, durability, and a belief that machinery should feel unfiltered. That attitude makes sense when you look at who Kawasaki really is. At its core, this is not a motorcycle company. It is a heavy industry builder, ships that cross oceans, aircraft components that live under constant stress, turbines designed to run hard for years without mercy. In that world, comfort is irrelevant. Survival matters more. When that mindset crossed into motorcycles, it never softened. Kawasaki machines often felt slightly misaligned with their era. Heavier than expected, louder than polite, visually aggressive before they were welcoming. They did not ask permission to be liked. Again and again, Kawasaki chose presence over refinement. Their engines felt over-prepared. Their designs prioritized function before friendliness. Riders were expected to rise to the machine, not the other way around. This was not rebellion for attention, it was consistency. Over time, that consistency creates something dangerous. When pushing boundaries becomes normal, curiosity changes shape. The question stops being how close you can get. It becomes why the boundary exists at all. And once that question takes hold, the next move is unavoidable. But before we dive into that, if this kind of rule-breaking engineering analysis is exactly what you come here for, hit the like button, drop a hype in the comments, and subscribe. Because that is what keeps us committed to bringing deep mechanical investigations like this to the channel. Every modern motorcycle is negotiated into existence long before the first part is drawn. Some limits are written to keep riders alive. Caps on power delivery, stability requirements, noise thresholds meant to prevent machines from becoming uncontrollable. Others exist to protect air, fuel, and heat, emissions targets, efficiency demands, thermal boundaries. Then there are competitive rules, created to keep racing fair, affordable, and technically contained. Together, these constraints form a system, not optional, not flexible, absolute. They do not merely influence motorcycles. They define what a motorcycle is allowed to become. Manufacturers learn to work inside that framework. You surrender potential in one area to gain approval in another. Performance is filtered. Design becomes a conversation with regulators. Progress requires permission. Kawasaki understood this system perfectly, which makes their next decision impossible to misunderstand. With the H2R, Kawasaki did not search for exceptions. They did not hover near compliance. They did not attempt clever interpretation. They walked away, no public roads, no emissions certification, no racing series, no governing body to answer to. The machine would exist nowhere the rules applied, and that exclusion was intentional. Once compliance disappeared, everything changed. Safety limits stopped shaping output. Environmental restrictions stopped shaping combustion. Competitive balance stopped shaping architecture. What remained was intent without restraint. This is the point where engineering stops negotiating with the world and starts defying it. And when that line is crossed, the consequences no longer stay theoretical. They become mechanical. Because the first place forbidden philosophy takes form is inside the engine itself. And here is a quick question for you. When a manufacturer builds outside regulation limits instead of inside them, does that make the machine more fascinating to you or more dangerous in your eyes? If you have ever followed a track-and-only build or non-compliant performance project, share your experience in the comments, because those real-world perspectives help shape how we approach future engineering breakdowns like this. Modern motorcycles follow an unspoken agreement about how power should be created. Engines breathe on their own. Performance is earned through displacement, rotational speed, and refinement. When more output is needed, engineers polish combustion, reduce resistance, and chase efficiency. Forced induction was explored decades ago, then quietly abandoned. Not because it failed, because it created problems no one wanted to manage. Supercharging disrupts the social order of motorcycle design. Power arrives too quickly. Heat becomes difficult to control. Throttle response turns aggressive. Emissions spiral. Reliability margins shrink. Most importantly, performance escalates faster than regulations can contain. So the industry made a quiet choice. They did not outlaw supercharging. They simply stopped selecting it. It became a path engineers learned to avoid. Not impossible, just unwelcome. That is why Kawasaki's decision matters. When the H2R stepped outside the rulebook, it also stepped outside accepted logic. Instead of asking how power should be delivered, Kawasaki asked how much could exist once consequences stopped shaping decisions. Supercharging was chosen because it overwhelms limits rather than respecting them. It forces air into an engine without negotiation. It pressures physics into cooperation instead of waiting for approval. That mindset fits a machine never intended to coexist with public systems. Once air is forcibly compressed, everything changes. Tolerances tighten, heat intensifies, control becomes fragile, the engine stops being a component. And a supercharged motorcycle engine already crosses a line most brands refuse to approach. But the forbidden part was not simply forcing air into the engine, it was how far Kawasaki was willing to take what came after. Because at that point, the next phase of the project stopped looking like motorcycle engineering and started borrowing discipline from an entirely different industry. And that is exactly what we need to understand next. Because without this hidden layer of design, the supercharger would overwhelm the engine long before its power ever mattered. Supercharging did not just raise output, it rewrote the survival requirements of the entire machine. Once air is forced beyond natural breathing, familiar motorcycle logic collapses. Margins tighten, heat rises violently, rotational stress compounds. At that point, performance is no longer the challenge. Survival is. This is where the H2R begins drifting away from motorcycling altogether. Instead of relying only on techniques developed for two wheels, Kawasaki looked outward. They borrowed thinking from environments where air is an enemy, heat is constant, and failure carries consequences far beyond inconvenience. Aerospace engineering does not design for comfort, it designs for inevitability. That perspective reshaped the entire machine. Airflow stopped being about cooling or appearance. It became structural. Pressure, turbulence, and stability were treated as loads that had to be managed, not side effects to be tolerated. Every surface served a purpose beyond aesthetics. Materials followed the same logic. Aerospace design favors predictability under stress. Components are built to remain consistent when pushed far past expectations. Weight matters, but certainty matters more. This is rare in motorcycles. Most bikes are tuned around human tolerance. The H2R reverses that relationship. The machine comes first. The rider is permitted to participate. That is why it feels less like transportation and more like an experiment that escaped containment. And once engineering reaches this level of pressure, the next question becomes unavoidable. Not whether it can perform, but whether it can endure. If you have ever studied or ridden a forced induction engine and felt that difference under load, share your experience below. And if this kind of deep engineering breakdown is what you value, hit like and subscribe. Because insights like yours are what make these technical investigations stronger. Borrowing aerospace precision solved the airflow problem, but it introduced another challenge at the same time. Because when pressure and rotational speed reach this level, standard engine components simply cannot carry the responsibility, which leads directly into the next layer of this forbidden engineering. The internal parts that had to be completely re-engineered just to keep the machine from tearing itself apart. Once air was forced, limits ignored, and permission removed, the next challenge became unavoidable: survival. At this level, engineering stops chasing improvement and starts preventing collapse. The goal is no longer to make the machine better, it is to keep it intact. A conventional superbike engine is built around expectation, anticipated loads, predictable temperatures, defined duty cycles. Regulations quietly intervene before stress becomes destructive. Emissions controls soften combustion. Tire grip limits acceleration. The system protects itself. The H2R removed those protections. With pressure and stress climbing far beyond normal behavior, ordinary internals would not wear down politely. They would fail violently. Components that live comfortably inside legal machines simply cannot exist here. Reinforcement became mandatory. Parts were redesigned for endurance, not refinement. Rotating assemblies had to remain stable under forces they were never meant to experience. Heat was no longer something to manage casually. It had to be absorbed and survived. This is the price of forbidden engineering. Every advantage gained demands repayment elsewhere. Weight increases, complexity grows. Tolerances narrow. Maintenance becomes a commitment. Kawasaki did not hide these consequences. The H2R does not pretend to be gentle or forgiving. It behaves like a machine built to endure abuse, not to accommodate error. Once reinforced to this degree, there is no path back to normality. You can't unstress materials. You can't soften components without compromising survival. The machine becomes locked into its own extremity. This is the point where the engineering no longer resembles anything designed for roads or race series. It becomes self-contained, designed to exist only under the logic that created it. And that is exactly where all of this engineering leads, to an outcome that no longer fits inside the normal definition of a motorcycle. In motorcycling, power usually has a place. Street bikes are designed to live within one ceiling. Race machines are allowed another. Each tier exists because everything around the motorcycle, the tires, the pavement, the rider, the rulebook, can absorb what the engine delivers without collapsing. The Ninja H2R ignores that arrangement. Its output does not simply exceed street limits. Plenty of machines have done that before. What makes the H2R unsettling is that it pushes far beyond racing expectations while refusing to belong to any race category at all. It generates more force than competitive systems were ever meant to regulate, measure, or contain. That's why its numbers feel different. They don't sound like bragging rights. They sound like caution signs. At this level, power stops being a performance tool and starts becoming a disruptive force. Traction models break down. Reaction time shrinks to fractions that human reflexes were never trained for. Mechanical response arrives faster than instinct can manage. The machine stops waiting for the rider to catch up. In organized racing, power is always paired with restraint. Air limits, fuel rules, weight floors. Those boundaries exist to keep machines comparable and survivable. Remove them, and power doesn't just grow, it changes behavior. The H2R creates a problem no category was designed to solve. It is too extreme for public roads, not only by law but by physics. Yet it cannot exist in professional racing either, because its presence would force every other machine to escalate or disappear. So it stands alone. No grid, no championship, no environment willing to absorb what it delivers. And that isolation exposes the same weakness every time. At this level, numbers don't measure performance. They reveal what the machine can physically survive. And that shifts the entire problem from speed to containment, and it forces a completely different conversation about what kind of structure can physically hold this kind of force together. By the time Kawasaki finished the engine, the real challenge had already begun. Once you create a power plant that aggressive, speed stops being the primary concern. Survival takes its place. The question is no longer how fast the motorcycle can move forward, but how long it can endure the forces trying to tear it apart from the inside. A conventional motorcycle frame is built around compromise. It allows controlled flex. It absorbs imperfect pavement. It communicates movement to the rider. Every one of those assumptions collapses in the presence of the Ninja H2R. The loads generated by its supercharged engine arrive harder, faster, and with far less forgiveness. Heat accumulates instead of dispersing. Vibrations amplify rather than smooth out. So Kawasaki did not design a chassis for the feel. They engineered one for containment. The steel trellis frame exists to resist distortion, not to offer feedback. Steel was chosen because aluminum would surrender too easily under sustained boost and rising temperatures. Each tube is positioned to anchor the engine, preventing torsional twists that could unravel stability at extreme speed. The swing arm tells the same story. Long, reinforced, and rigid, it stretches the wheelbase to suppress lift and counter violent torque reactions. This is not agility-focused design, it is mechanical restraint. Heat control becomes structural. Exhaust routing, carbon bodywork, and airflow channels serve not just aerodynamics, but thermal survival. When temperatures exceed anything a road motorcycle would ever see, the frame itself becomes part of the cooling solution. Suspension follows that philosophy. Ultra-stiff race-grade components are not tuned for comfort. They exist to preserve geometry when acceleration tries to compress the rear and unload the front at the same time. At these speeds, uncontrolled movement is not feedback, it is failure. What results is a machine that does not adapt to its rider. It allows one to remain aboard. This structure does not communicate, it enforces. And even that is not enough on its own. Because once the engine and chassis are barely under control, the next weakness becomes human reaction itself. When a chassis is engineered to restrain force rather than communicate it, something fundamental about riding changes. The moment feedback disappears, enforcement takes its place. If you have ever recognized that shift beneath you, leave a note below, because from that point on, the margin for error is no longer mechanical. And if tracking where that margin disappears is why you watch these breakdowns, support the work by liking and subscribing. By this stage, the H2R has already crossed a hard limit. The engine operates beyond natural restraint. The chassis exists to keep destruction contained, and one final reality becomes impossible to ignore. Human reflexes are no longer fast enough. At the acceleration and velocities this machine produces, reaction time stops being an advantage and starts becoming a vulnerability. Throttle inputs arrive before consequences can be fully processed. Rear tire grip can disappear in the span of a heartbeat. Front-end lift does not build gradually, it happens instantly. No amount of experience can compress biology to match that level of mechanical aggression. This is where electronics stop being optional. On the H2R, control systems are not performance enhancers. They are survival mechanisms. Traction control does not smooth delivery for comfort. It intervenes to interrupt instability, monitoring wheel speed differences and cutting power the moment torque overwhelms available grip, long before a rider could feel it. Wheelie control serves the same purpose. Under boost, the front tire wants to leave the ground almost immediately. Once that happens, steering authority vanishes. The system forces the tire back onto the surface, not to make the ride pleasant, but to preserve directional control. Even engine braking and power mapping are not conveniences. They exist to shape force into something temporarily manageable. Without electronic oversight, throttle modulation would demand precision beyond human capability. One misjudgment would not result in discomfort, it would end the ride instantly. These systems do not make the H2R forgiving. They make it barely operable. They do not eliminate danger, they postpone it. This reverses the usual role of motorcycle electronics. On road bikes, software adds smoothness and approachability. Here, software exists because human limits have already been exceeded. The bike does not trust the rider. The electronics are not partners, they are overseers, and even their authority has limits. Because once speeds climb this high, control is no longer just about rider and machine. The surrounding air itself becomes a force that must be confronted next. By the time electronics are working to keep the H2R controllable, another force has already taken command, the air itself. At extreme velocity, air is no longer empty space. It becomes resistance with weight, pushing back harder with every increase in speed. Most motorcycles avoid confronting this directly. Large aerodynamic surfaces introduce instability, unpredictable reactions to crosswinds, and steering sensitivity that becomes dangerous outside controlled settings. The H2R does not avoid that problem. Its aerodynamics are not focused on drag reduction alone. They are designed to generate force. Drawing from aerospace thinking, fixed carbon fiber winglets produce downforce that presses the front tire into the surface as speed builds. This is not visual drama. Without that pressure, acceleration would lift the front end beyond what suspension and electronics could manage. Traditional motorcycles rely on geometry, rider position, and throttle control to limit lift. The H2R exceeds those methods. At full output, only air, the same medium resisting motion, can be repurposed to restore stability. That is why these winglets are rigid and uncompromising. Adjustable surfaces would introduce variables the machine cannot tolerate. At these speeds, bodywork stops being decoration and becomes structure. And that choice carries consequences. Aerodynamic aggression reduces adaptability. It demands clean surfaces and predictable airflow. The machine becomes less forgiving by design, which is why the H2R does not pretend the street is a suitable place to exist. And that brings everything into conflict once reality is introduced. By this point, the conclusion is unavoidable. The Ninja H2R cannot exist on public roads because it was never engineered to survive them. Not legally, not mechanically, not structurally. Public roads are built around uncertainty, uneven pavement, changing grip, debris, traffic, human error. Every street motorcycle, no matter how fast, is designed with tolerance in mind. They absorb imperfections, they forgive small mistakes, they recover when conditions change without warning. The H2R rejects those assumptions. Its engine delivers force so abruptly that traction depends on controlled surfaces and uninterrupted electronic correction. On public pavement, grip can change faster than sensors can respond. One patch of dust or an unexpected surface change, and the balance the machine relies on disappears. The chassis compounds the issue. Built for rigidity and containment, it offers no margin for broken pavement. What stabilizes the bike at extreme speed becomes a liability in street-level chaos. The suspension preserves geometry rather than softening impacts, reducing feedback when adaptability is required most. Aerodynamics only deepen the conflict. Downforce rises with speed, but so does sensitivity. Crosswinds, passing traffic, and turbulent air introduce forces. The H2R was never designed to negotiate. Heat completes the picture. Exhaust temperatures and cooling demands assume constant motion. Stop-and-go traffic breaks that assumption immediately. None of this makes the H2R irresponsible. It makes it precise. Every engineering choice points away from public roads. Making it legal would require dismantling the very logic that defines it. And the street is not the only place where those limits appear. Because even in racing, permission has boundaries. If public roads represent uncontrolled reality, then racing represents something very different. Order. Racing organizations exist to make speed survivable. Their rule books are not barriers to progress. They are containment systems. Displacement limits, induction bans, and technical regulations exist so competition remains comparable, repeatable, and controllable. The Ninja H2R undermines those foundations. Its supercharged engine alone removes it from nearly every major motorcycle series. Forced induction is heavily restricted or completely prohibited because it destroys parity. Power stops scaling predictably. Development shifts away from rider skill and setup and toward boost pressure and exotic materials. Racing bodies do not reject this out of fear. They reject it because it breaks the structure that makes racing possible. Even if the engine were allowed, the conflict would only deepen. The H2R applies acceleration and load beyond what production-based circuits are designed to handle. Tire wear models, braking zones, runoff areas, and corner entry speeds all assume a defined performance ceiling. This machine exceeds that ceiling in ways infrastructure cannot absorb. Aerodynamics create another fault line. Fixed winglets that generate downforce introduce speed-dependent advantages. Most rulebooks intentionally prohibit. Once airflow becomes dominant, competition turns into an engineering escalation instead of a test of execution. Safety governance seals the outcome. Racing does not regulate machines alone, it regulates consequences. A motorcycle capable of overwhelming its own safeguards introduces unacceptable risk for riders, officials, and circuits alike. So the H2R is not dramatically banned. It is simply unclassifiable. There is no category that can contain it without rewriting the system around it. And racing cannot exist around singular machines, which makes its exclusion revealing. Kawasaki did not build a motorcycle that failed to qualify. They built one that never sought qualification at all. To understand what permission looks like, the only answer is to examine the version that accepted it. To understand what permission looks like, nothing new had to be invented. Things had to be removed. The Ninja H2 exists as the answer to a question the H2R never asked. How much of this machine can survive contact with the real world? What remains once regulation, safety, and daily usability are reintroduced? Power is the most visible difference, but it is only the surface. The supercharger is retuned to deliver boost progressively rather than violently. Output is capped not because engineers lacked capability, but because beyond a certain threshold, control systems begin fighting the engine instead of working with it. The H2 is not slower because it is weaker. It is slower because it is allowed to function in reality. Then come the removals. The winglets disappear. Fixed downforce creates instability at road speeds and unpredictable reactions in crosswinds. What stabilized the H2R on track would undermine control in traffic. Neutrality replaces aggression, trading drama for survivability. The chassis softens by design. Geometry adapts to imperfect pavement. Suspension gains compliance. Feedback returns. Where the H2R enforces structure, the H2 negotiates with the rider and the road. Electronics change purpose as well. On the H2R, software prevents immediate failure. Here it manages experience. The machine anticipates mistakes and is built to recover from them. None of this weakens the Ninja H2. It defines it. And in doing so, it exposes the nature of the machine that refused permission entirely. At this point, the difference is no longer about speed or legality. It is about intent. If this contrast between permission and refusal is what is keeping you here, take a moment to support the breakdown by liking this video. And if you want early access to where this investigation goes next, membership helps make that possible. Because what comes next is not about what Kawasaki created. It is about what this machine refused to surrender. Owning a Ninja H2R does not begin with riding. It begins with acceptance. There is no title, no registration, no path to insurance. Instead, ownership comes with a manufacturer's statement of origin, a quiet confirmation that this machine is not recognized as a vehicle in the normal sense. It arrives without a destination. It can be transported, maintained, and awakened, but it does not belong anywhere functional. That reality reshapes the relationship. The owner is not a rider in the traditional sense, but a custodian. Every startup is intentional. Every movement is planned. Freedom is replaced by responsibility because a machine built without compromise cannot be handled casually. And that leads to the final truth. The Ninja H2R was never meant to be understood as a motorcycle. Motorcycles exist inside systems, roads, races, laws, communities. The H2R exists outside them by design. It shows what happens when engineers stop asking what is allowed and focus only on what is possible. And machines like this are not meant to be consumed quickly. If you want to keep exploring engineering that lives outside accepted limits, continue the journey with the next breakdown on your screen. Stay connected by subscribing, support the work with a like, and for those who want to go deeper before anyone else, early access is available through membership.